Hello again. Hi. So this second video, I'm going to show attaching the lines to the vehicle. Now, this is the same gauge set I used in the previous video. Remember, before we attach it to the vehicle, we're going to make sure these valves are tight because we don't want the internal channels open in this gauge set. We're going to make sure the high and low side are backed off completely. And we're going to make sure all of the lines are snug on the gauge set. And all these you just hand tighten, you don't really use wrenches on them. That's why there's no place to put a wrench. So that's all set. I wish I could get a little more clarity on this video, but this is what we have to live with. So my fittings, I'm going to take this camera off here. Second. Fittings are right there. The one farther forward is the low side, and the one in the back is the high side. The high side has the larger fitting. You might be able to see on top. I can't really see it, but that's an L on the low side. Okay, so let's see if I can position this for you to see me attach it. Okay, we'll try that. And I'm going to detach the low side. Take off my low side cap. Put it here on the table. And I'm going to take the gauge, pull it back slightly to where it starts to go on the line. And then I'm going to push it the rest of the way. Actually, that one went right on, didn't even have to click it. Take the high side cap off. And my high side gauge line. Pull the fitting back and get it started. And this one also goes on so easy, it doesn't even clip. Okay, so they're both on. Now, let's go back and look up the gauges. So this gauge, this is the low side gauge, reads about 100 psi. The high side gauge reads about 70 psi. Now, an inexperienced technician might look at these and say, oh, I've already got pressure in my system. It's kind of odd. I've got different pressures from one side to the other, but good thing I have pressure in there. Had we not known these gauges had pressure in them before, we might think the pressure we're seeing is actually out of the car, but it's not. I haven't opened the valves yet. So beware of this, because if you hook up a gauge set that has no pressure and you don't open the valves, they're still going to show no pressure. So you might think the system is empty. That's a common mistake that freshman technicians make. So you got to make sure you open the valves, and that way you'll know what the pressure is. So once I open the valves, these gauges will read what's called static pressure. It's the pressure that's in the system when the car is shut off and the air isn't running. So that's static pressure, and we expect it to be somewhere between 80 and 100 psi. So I'm going to hang this back up. I'm going to go back over here. And I'm going to open these two valves. Here's the low side. Low side still reads 100 psi. The high side did read 80. I'm going to go ahead and open it up. And the high side went up just a bit. It reads 90. Actually, both gauges read about 95. So this system is fully charged, obviously. Shows 95 psi on the low side, 95 ps on the high side. It's what we call balanced or equalized. So the low side and the high side right now are equalized. There's no compressor pushing the refrigerant through the system, so it's not meeting up with the restriction device and creating a high side in front of the restriction device and a low side behind the restriction device. So now I'm going to go ahead and start the car up, turn the air on, and we'll see what we have. Try and position this gauge so you might be able to see the numbers move. All right, well, that's the best I can do. So here we go. Okay, so now what we see is the low side only dropped down to about 80, and the high side has gone up to about 150. Now the car is idling right now, so let's see what we get when we increase the RPM. This car is drive-by-wire, so I have to get inside and do that. Okay, so the low side on this gauge only dropped down to about 60. The high side went up over 200. It's a very chilly day. It's only about 65 degrees out here. So even though I've turned the air conditioner inside all the way down to its coldest setting, it's not really pushing very much refrigerant through the system. Because it's not pushing very much refrigerant, the high side is going up somewhat, but the suction side of the compressor, which sucks on the low side, is not creating very much suction. And that's because it doesn't want to push too much refrigerant through it because it doesn't need that much to make the inside of the cabin get cold. So on this particular car, this is a 2016 Honda Odyssey van. It's got a thermostatic expansion valve which um, opens and closes based on the need. Right now, it doesn't need much refrigerant in the evaporator, so the TXV is opening up I'm sorry, it's closing down a little bit, not letting much pressure go into the evaporator, not letting much refrigerant in there. And the suction side of the compressor, it's also got a variable rate compressor, so the compressor isn't pushing much refrigerant, and that means the low side isn't pulling down that low. The high side's going up to a respectable amount, up to about up to a little over 200. But the low side isn't going near as low as we would expect it. Now, if this were a summer day, a couple things would happen. The evaporator would be warmer, so the TXV would open up and let more refrigerant into the evaporator. The compressor would tighten up and start pushing more refrigerant around the system. That would create a much lower low side, and the high side might go up somewhat, maybe to about 250. Okay, now we're going to go inside and take a look at the HVAC system on the inside of the car with a thermometer. That'll be in the next video. Thank you.